Here's an example in which we're converting the point with Cartesian coordinates -2 and -2 square root of 3 to polar. Enter exact values with r greater than 0 and theta between 0 and 2 pi. Okay, so we're starting with the point -2, -2 square root of 3. Okay, so how do we go to polar coordinates? Well, if you look at the notes right here that I gave you at the top of Module 5, these notes, it goes to go to polar, starting with a rectangular or Cartesian, same thing. Plot the point first off. Don't skip this step. A lot of people want to skip it. Plot the point to see which quadrant it is in and calculate r squared of x squared plus y squared. So let's plot it. Let's do what it says there. So it says it's back to and down, whatever minus, I don't know what that is. I'm just going to go, yeah, about like that. So it's back to down to square root of 3. So it's in the third quadrant, isn't it? And then we can calculate r. R is the square root of x squared plus y squared. That's because it's a little triangle, isn't it? Go over and down, like that. So in other words, it's back to and it's down to square root of 3. Right angle, this is r. So it's a Pythagorean theorem, basically. So r is the square root of x squared, -2 squared, plus y squared, -2 root 3 squared. Okay, so let's figure that out. R is the square root of, what's that going to be, 4 plus, now do you know how to do this? You square the 2, so that's going to be 4, and you remove the root on the 3, so it's a plane 3. Did you see what happened there? So the 2 hit both of these guys, the 2 power, and it squared the 2 to become 4, and it removed the root on the 3. The 2 power canceled the root to become a regular 3. Didn't square the 3 to become 9 because that root canceled it out. So what do we get then? 4 plus 12, which is the root of 16. So r is just nice, clean 4. So we've got r, and they want an exact number. They want a parenthesis r, comma, theta. Notice they say exact values, so no decimals, no rounding. All right, so we got r. That was the easier part. Now we got to get theta. So if you look down here at the notes, getting theta is most of the work. How do we get theta? Find the angle. Oh, a degree, well, that shouldn't say degree. It should say degree or radian, depending on the problem. In this one, we're in radian mode. How do we know? Because right here, they say make your answer between 0 and 2 pi in radian. Oh, yeah, they say the actual word. I don't need to be more subtle. Radians. So we're actually going to be in I'll get rid of that, radian mode. So how do you do it? Theta is the tangent inverse of the absolute value of y over the absolute value of x, right there. So, and that's called the reference. That's not the actual theta yet. The reference theta is tangent inverse absolute value y over absolute value of x. So that's tangent inverse absolute value. What's y? Yeah, I don't have room there, do I? So the reference angle, tangent inverse of this is y, this is x. It's absolute value, both of them, so it's going to be positive 2 root 3 over positive 2 because of the absolute value signs. Make both of those guys positive, right? The y over the x. And then you can tell what happens here. These 2's cancel. So the reference theta is inverse tangent square root of 3. Hit the buttons on your calculator, and let's see what we get. When I hit tangent inverse, and we're going to be, yeah, maybe we should, well, yeah, we're in radians. We want to be in radians right now, right? So radian mode. Make sure you're in radian mode. So hit tangent inverse of the square root of 3. I'm getting 1.0 1.047197 radians. That's radians. Now, what are we going to do with that answer? Are we done there? No, that's just a reference theta. That's not the actual theta. How do you get the actual theta? Well, going the wrong way. That depends on the quadrant you're in, right? That's why I wrote up all these notes for you. So you find this is the reference. It's really just quadrant 1 because we made x and y positive with the absolute value. So now you got to go to whatever quadrant you're really in. What quadrant are we in? That's why we plotted it on the first step. We're down here in the third quadrant, right? That's where our point actually is, back to down to root 3. We're in the third quadrant. So the third quadrant, you got to take 180 or pi, depending on which mode you're in, plus the reference angle. 180 plus pi, or pi plus reference angle. So the actual angle, is pi plus the reference. So it's pi plus the 1.047197. That's the actual theta. So theta, use your calculator. Use the actual pi button now. I'm getting 4.18879. Now, that's in radians, and the problem is they're not going to take that answer. You think, why not? Well, because they said exact values, no decimals. Well, what do we do? That's what we got. Now we convert it. We can do that. Let's convert these radians. Let's go to degrees. Even if you think, well, they want, I'll show you why. Let's just do it. So 4.18879 radians. So how do you convert? Remember how to convert? This is over 1, really. You've got to, this is a 1. You've got to put radians on the bottom so radians cancel and degrees on the top. Like so. And then there's 180 degrees in pi radians, right? So if you do that, you take 4.18879 times 180 divided by pi, right? I'm going to, on my calculator, 4.18879 times 180 divided by pi. I'm going to change to degrees. Radians will go away because I made them cancel. Use the pi button again. I'm getting 240 degrees. So we made it to degrees, and now, having done that, now you can convert that. Now that it's a clean, now you might get, if you rounded somewhere along, I didn't round it all. I used all the decimal points on my screen. Actually, I used the answer button all the way through, so I was using everything. But if you rounded at some point, you might get like 239.999 or 240.000, whatever. It's exactly 240. Remember, they want exact answers. It is exactly 240. But we have to change that now. You think, why did you change that to degrees? We need radians. Right. I'm going to change it back, but now I can bring the pi into the mix more easily. I'll put degrees back down here in the bottom, and I'll put radians up here. Remember, it's pi radians for 180. You might think, well, that's just undoing what you just did. Yeah, but this way I can get an exact value. This is over 1, so I can get 240 pi over 180, you see? I just went straight on the top, 240 times pi, 1 times 180. And then I can just reduce that fraction. Just reduce the 240 over 180. That's 24 pi over 18. I just divided top and bottom by 10, and then divide top and bottom by like 6. Most of your calculators will do this for you automatically. Get 4 pi over 3. There it is. That was a little bit of trickery to get the exact angle, wasn't it? 4 pi over 3. So let's go back up here. 4 pi over 3. So again, how did I do that angle? Let's run through it again. That was tricky. I had to find the reference angle, inverse tangent. This is inverse tangent right here, of absolute value of y over x. I did that. Hit the buttons on my calculator, got that reference angle, went to the notes, and they told me if you're in the fourth quadrant, you got to take 2 pi minus the reference. or I'm sorry, if you're in the third quadrant, you got to take pi plus the reference. So I did that. I took pi plus the reference. Got this, but that was radians, and it was a decimal radians. So I went ahead and just converted to degrees. Even though I need radians in the end, I converted to degrees, and I got 240, which was clean. Or maybe you get something close. You know it's exactly 240. Then convert it back. Pi over 180, you get this fraction, which you can reduce to get an exact fraction instead of a rounded number, 4 pi over 3. That's radians. There's our answer. That's not easy to find that, right? Once you had 240, let me show you the unit circle up here. One other idea before I leave you. 240, 4 pi over 3. There it is on the unit circle. You can just nail it down that way once you found that it was that angle. Where are we? I'm lost in my problem. There it is.